This question belongs to 2010 October November paper 1-2 and the question number is 7. So it says that a student throws a ball in the positive direction vertically upward. The ball makes an elastic collision with the ceiling, rebounds and accelerates back to the student's hand in a time of 1.2 seconds. So we have to find which graph best represents the acceleration of the ball from the moment it leaves the hand to the instant just before it returns to the hand. So what's happening here is a ball is, let us say if this is the position of the hand and if this is the ceiling. So here she throws the ball, it rises up, 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 it collides with the ceiling and then falls back. The first thing that we have to remember is when we throw something up, the value of acceleration is negative. The value of acceleration is negative. It's because when the body goes up, the velocity is in the upward direction, but it decreases. It's because the force is in the downward direction, force of gravity. So that's why the direction of acceleration is also downward, and as well as this a is negative. So if I go through the graphs here, in this graph a is positive, so this does not qualify. In this graph a is positive, so this also does not qualify. And in these two graphs a is negative, so these two might qualify. Now as it goes up and up, so what's now happening here is as it goes up and up, the force is in this direction, and when it strikes the ceiling, so let's say it strikes the ceiling here, so let me draw it somewhere here. So it goes up, 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 and it strikes the ceiling. When it strikes the ceiling, the downward force on the ball increases. It's because initially it was Fg only. Now there is addition of force due to the ceiling as well. So this means the downward force should increase. That means the downward acceleration should increase, which means that the negative acceleration, downward acceleration means negative acceleration, that acceleration should increase for a moment till the ball is in collision with the wall. So that's why among these two, the increase of downward acceleration is only depicted in this graph. So this should be the correct answer. Now one thing that we have to remember is if I go through this time, this is 1.2 seconds, and here the time for upward flight is longer, time for downward flight is shorter. But here the time for upward and downward flight is not so much different. Here is a lot of difference, and here it is not so much of difference. So that's why this could be the proper answer, because the time cannot be so short here. The velocity might increase slightly, but it cannot be so great that it is taking less time. So it must decrease slightly only, which is shown here. So the answer should be choice number D.